So where are where are we in our examples? So we have this. Okay, we're done with this and here. So this was the assignment. All right, so let's work and discuss about t-test for a mean. When to use t-test for a mean statistical tool. This is gonna be used, guys, when your population standard deviation is not given or is unknown. Okay, so I'll repeat. We are going to use t-test for a mean when the population standard deviation is not given in the problem. As you can see, the formula is still similar to the z-test, and for the only difference, guys, is the symbol. The symbol is now coming from the sample mean. The S here stands for the sample standard deviation, and there's additional thought or idea of degrees of freedom. I believe I was able to cover this, but if not, I'm going to discuss this. So let's have this example. A medical investigation claims that the average number of infections per week at a hospital in a particular area is 16.3. And a random sample of 10 weeks had a mean number of 17.7 infections. The sample standard deviation is 1.8. The question here now is there enough evidence to reject the investigator's claim at alpha 0.05? Assume the variable is normally distributed. So right after you read the problem, guys, when it comes to the examination, you always need to ask yourself, what test should I use? Is this going to be a z-test, a t-test, or what? So that's your pre-qualifying question that you should ask yourself before continuing answering the problem. The qualifications for you to be able to use z-test or t-test, it has to be z-test if and only if the population standard deviation is given, okay? It has to be t-test if and only if the population standard deviation is not given or unknown. So if we're going to read the problem that we have here, the standard deviation that we have, guys, is actually coming from the sample size that we have, okay? And that means to say that we don't have the population standard deviation. This means that we're going to be using t-test for this problem here, okay? The steps will still be the same. So we still have 5 steps similar to z-test. But the critical values, the test statistic will be different. But the step 4 and 1 and 5 are all the same. They are just the same process. So let's start with step 1. Our null hypothesis here, guys, is still we are dealing with means. Our mean is 16.3, right? And the alternative hypothesis is not equal to. Medical, okay, the average infection was the area, the random. Okay, it's not equal to. It didn't say if there is, it didn't say if it's greater than or less than. So the safest one or option that we have is not equal to 16.3. Okay? And the claim here, guys, is the null hypothesis. So here, a medical investigation claims that the average number of infections per week at a hospital in a particular area is 16.3. So this is the claim. Okay. Now, step 2 is going to be identifying the critical values from the appropriate table. Now, since we are using t-test here, guys, we're going to be using t-test distribution or t-table distribution for this case here. So I'm going to open up a new tab, t-table, and images. Let me, oops, this is YouTube link. I need a table here. So here, I hope you guys can see this. I'm going to take a screenshot of this item here and then paste this in the here. So I hope it's visible. The numbers are visible on your end. Just please let me know if it's not so that I can make it a little bigger. There. So first thing that you need to consider is the degrees of freedom. The degrees of freedom, guys, is n minus 1. N stands for the sample size. The sample size that we have in the given is given by 10, a random sample of 10 weeks. So 10 weeks, rather. So our degrees of freedom is 10 minus 1. We have 9, right? And our alternative hypothesis tells us that this is a two-tailed test. Two-tailed test. And then our alpha given is 0.05. So we're going to take a look at on our table, guys, on the T table to identify the critical value. So our degrees of freedom is 9, so we should be looking here, there. You go, and this is a two-tailed test, so we should be also looking this one here. And our alpha is 0.05, so which here is 0. That's 1, and they're two-tailed. And then we're just gonna go and see the intersection of 9 and that value there. So we have a critical value of 2.26. So in other words, our critical value, since this is a two-tailed test, 1 for negative and 1 for positive. So 1 for 2.262 and 1 for negative 2.262. So this is the rejection area, and the unshaded area is the acceptance area. So we're done with step 2. Our critical values are negative 2.62 and 2.262. 2.262. Now let's work on computing the test value. The test value, guys, is given by the formula sample mean minus population mean over sample standard deviation square root of n. So our sample mean in the problem is a random sample of 10 weeks. So we have n equals 10, had a mean number of 17.7. So our sample mean is 17.7 minus the population mean is 16.3. 16.3 over the sample standard deviation. We have sample standard deviation, we have 1.8. 1.8 over square root of 10. So let me grab my calculator and let me simplify it. 17.7 minus 16.3 over 1.8 square root of 10. We have 2.46. 2.46. So now, our step 4 is the decision making. Do we have to accept the null hypothesis or reject the null hypothesis? Clearly, in step 2, our critical values are 2.262 and negative 2.262. Our test statistic value belongs to something or somewhere within this portion here, 2.46. This means to say that our decision for step 4 should be to reject the null hypothesis. So reject the null hypothesis. Null hypothesis. Which means to say that which would lead us to our conclusion that since we are rejecting the null hypothesis, we can say there is enough evidence to reject the claim. That's one of our conclusion statements because the claim here, guys, is the null hypothesis. That's one. You can also say, indeed, or it's true that the average number of infections per week, it's true that the average number of infections per week is not equal My bad. Yeah, is not equal to 16.30. So these two things that you can state as your conclusion. Okay? One moment. Hope you're able to get it with respect to the first example that I just discussed today. Let's proceed to the next part, or next example. So here, there is enough evidence to reject the claim. This is what I wrote here, guys. There's enough evidence to reject the claim. So here, we have this example. An educator claims that the average salary of a substitute teacher or substitute teachers in school districts in a local district is less than 870 per day. A random sample of 8 school districts is selected, and the daily salaries are shown. Is there enough evidence to support the educator's claim at alpha 0.10? Assume the variable is normally distributed. So here's the thing. If you notice, as I've mentioned earlier, you need to pre-qualify the problem, guys, if it's going to be a z-test or t-test, because during examination, I wouldn't tell you if it's going to be a z-test or t-test. You had to decide. And what are the pre-qualifications? The priority is the population standard deviation given? So you have two answers, either yes or no. If it's a yes, then you have to use z-test. The next answer should be, or the next answer can be no. The population standard deviation is not given. So if it's not given, or if it's unknown, you have to use t-test for a mean. So looking at this problem that you can see here, guys, do we have a standard deviation from the population? The answer is no. It didn't actually mention it. Right? So this means to say that this problem will be using the t-test for a mean. Let me scroll down and paste a screen cap of this item here. Okay. All right. So since this is a t-test, we know that we are going to be using the t-table. So let's start with null hypothesis, an alternative hypothesis. So in this case here, the null hypothesis would be equal to 870, and the alternative hypothesis is not, or rather less than 870. So guys, I know this section or this block is very silent whenever I ask questions. I will be assuming since you don't write anything on our chat box as our questions, or questions you don't write your questions in our chat box, I assume nga nakasabot sa akong discussion ha. So this is our first statement or first step. The second step, guys, is going to be critical value. So we have a one-tailed test. Degrees of freedom is n minus 1. Our n here is 8. Minus 1, we have 9. And our alpha is 0.10. So using the same table, I'm just going to scroll this down. And then let me erase this para makita niyo. So the degrees of freedom is 9. So we have here. And then it's a one-tailed test, so we should be focusing on this one here. and then the alpha is 0.10. So along the one-tailed test, we're going to look for 0.10. Where are you? Here. This is the one. And then we're going to look at the cross or the intersection of 0.10 under one-tailed test and the 9 of degrees of freedom. So the critical value is 1.383. So since this is what on the left side of the graph, it should be negative 1 point, what was that? 1.383. Okay, so here. There you go. So if our test statistics, test statistic belong to the left, then we should be rejecting the null hypothesis. If our test statistics belongs to the right, then we should be accepting the null hypothesis. So for us to be able to know where our test statistic belongs to, let's solve it. So the formula would still be T sample mean. Yep.
I think 9 something sa DF, sir. Is it supposed to be 7, sir?
Oh yeah, it should be supposedly 7. Thank you so much. Who was
Thank you,
that?
sir.
Kariel? Was it Kariel? So this is 7. Then our critical value should be different. So this is not 9. Okay. So it should be here, there. And that would give us 1.415. Okay, thank you. So this is negative 1.415. There you go. All right, so we're gonna be solving for the statistic using the formula, guys. S over square root of n equals our sample mean. We don't have it here in the problem, right? As you can see, you don't see it. It didn't actually mention the 870 is a population mean. However, we are given the 8 sample salaries of a substitute teacher. We have 680, 590, 890, 900, 740, 950, 960, and 920. So this means to say that this is already our sample. We just have to solve our mean from here. So getting your calculator, 680, 590, 890, 900, 740, 950, 960, 920. Sorry, it should be 920. The average that I have is 828.75. So we have 828.75 minus 870 over, we just need to solve again the sample standard deviation. And the sample standard deviation will be solved using the data that we have here, guys. So I hope you can still remember how to solve for the sample standard deviation. What you would need to do is this. You do this, 680 minus the mean, 828.75 squared plus 590 minus 828.75 squared plus kanina sad plus dot until such time maabot kas kinalasan nga number. So we have plus 920 minus 828.75 squared over kung pila sila kabuok 8, and you get the square root because without the square root you are solving for the variance man. So using my calculator, the sample standard deviation should be 130.43. So this is the value that we're going to be substituting here, 130.43. So let's continue solving for T. 828.75 minus 870 over 130.43, sorry, 0.43, oops, divided by square root of 8, I have negative 0.89. Yeah. So, step 4. Step 4, guys, is the decision-making grid. Do we have to accept the null hypothesis or reject the null hypothesis? We're going to take a look at the illustration that we have in step 2. If you notice, 0 is somewhere located here. And our test statistic is actually negative 0.89, which is somewhere here. This means to say that we have to accept the null hypothesis because negative 0.89 belongs to the acceptance region. So accept HO. Number 5 is our conclusion. Since we are accepting HO, yes, we can actually agree, yes, it's true that the average salary of substitute teachers is, how much is that? 870 pesos. Question.
None so far, sir.
Okay. Sige. Let's work on p-value method using the test status or the t-test gihapon. So I'm going to take a screenshot of this. No, I think this was actually covered. I mean, there's an explanation. Okay, so let's work this out using p-value method. So basically, naatay traditional method and p-value method for t-test. A physician claims that joggers' maximal volume oxygen uptake is greater than the average of all adults. A sample of 15 joggers has a mean of 40.6 miles per kilogram. I think it's miles, ml. Oxygen, ml per kilogram. Okay. And a standard deviation of 6 ml per kilogram. If the average of all adults is 36.7 ml per kilogram, is there enough evidence to support the physician claims that alpha 0.05, assume the variable is normally distributed? So here again, we need to pre-qualify if the problem is dealing with t-test for a mean or z-test for a mean. Let me give you 2 minutes to think about it if it's going to be a t-test or z-test. All right, so for this problem, guys, the test that we are going to be using is t-test for a mean because we don't have the population standard deviation. What we have instead is the standard deviation, even though it didn't actually specify if it's from sample or population. But if you're going to read the problem again, it says that a sample of 15 joggers has produced a mean of 40.6 miles per kilogram, and that standard deviation of 6 miles per 6 ml per kilogram is coming from the sample of 15 joggers. So that's, even though wala siya specifying a sample standard deviation, as it's already meant nga ang kanang nga standard deviation nga 6 is already coming from the sample of 15 checkers. So this means to say that this is a t-test. Okay? So state the null hypothesis and identify the claim. So the null hypothesis would be equal to 36.7, and the alternative hypothesis will be greater than 36.7 because of what we have here, and the claim is the null hypothesis. So here is your hypotheses, the null and the alternative. Questions so far, none? Okay, so let's proceed to step 2. Step 2, guys, for p-value method is directly solving for the test statistic. So you just have to substitute the values that you have already known. The sample mean is 40.6. The population mean is 36.7. The sample standard deviation is 6 ml per kilogram, and the sample size is 15. You should get 2.517 or 2.52. Take note of that number because that's going to be used in step 3. So you can use, or you can get your calculator. I'm going to give you 1 minute to confirm the answer if it's really 2.517. Thank you so much for confirming the answer. I appreciate it, Renee and Janine. So it's 2.517. So take note of this number because that's going to be used in step 3. Let's proceed to step 3. And determining the specific p-value for t-test, guys, is not possible. Okay? Compared to the z-test that we have before, it is possible to determine the specific p-value because makita naman na tong area sa table. However, in this case for t-table, guys, we cannot specify it. But what we can do is we can determine the interval where that t value that we have just solved in step 2 belongs to. So let's work this out. Let's start with degrees of freedom na n minus 1. The n that we have here, guys, in this example is 15. So the n minus 1 is 14. So if you notice at the bottom part here, I place this 14 row or 14th row under an oblong or a shape. Now, along these degrees of freedom, look at the value where this value 2.517 belongs to. So if you notice, I have already in place those two values inside the green box, 2.145 and 2.624. Nganong kaniman ang gipili? Nganong kana man ang napili? Dili ako ang gipili di ay. Nganong kana man siya, so nganong duha ka ng duha ka book number? It is because somewhere in that interval, this 2.517 belongs to. So nakabantay mo nga between 2.145 and 2.624, this 2.517 belongs to that interval. That's why mao na ang gipili. And then you scroll up to look for the p-value. Ang imong option is kaning 0.05 and 0.02 and 0.025 and 0.01. Asa may pilion nimo ani? You're gonna be picking the tail depending on your alternative hypothesis. So let's go back to our alternative hypothesis here. Our alternative hypothesis is a one-tailed test, greater than man. So here, that's why I encircled this part here, not this part here, because this interval kaning 0.05 and 0.02 is for two-tailed test. This means to say that the p-value, guys, belongs to this interval. Okay? So that's where your p-value lies within. Now, your step 4 is your conclusion. If either you're going to accept or reject the null hypothesis. So here, your p-value falls somewhere within 0.01 to 0.025. If you notice, all the numbers inside this interval are all less than 0.005. This means to say you get to reject the null hypothesis. Has then been has or had these numbers greater than or equal to 0.05, then you have to accept the null hypothesis. Here, mga mohang cases. So this means to say that we're gonna be rejecting the null hypothesis. Let's go back to the first example or the first statement here. We are rejecting this. We are accepting the null hypothesis. This means to say that there is enough evidence to support the claim, which is the mean of the oxygen uptake is greater than 36.7 ml per kilogram. So here, there is enough evidence to support the claim that the jogger's maximum volume oxygen uptake is greater than 36.7. I'll give you 3 minutes to internalize the solution and think about it. All right. So, okay, no questions. Let's proceed to another type of test. But before we discuss another type of test, guys, these are your pre-qualifications. What if Billy gives a table and degrees of freedom? Okay, I'm going to show you guys this one here. Okay, see, if you notice, guys, the sample sizes are ranging from 30 to 40 to 60, 80, 100. So let's say, for example, your degrees of freedom is 42. I'm no, sorry. Your sample size is 42. Tama? And then 42 minus 1 is 41. So sa may gamiton ako, sir, is it 40 or 60? You use the closest one or the closer value. So in that example, Lauren, if your sample size is 42, and then you do minus 1 for the degrees of freedom, which is technically 41, then you choose the closer one, which is 40. So use 40 as your degrees of freedom. Okay? But if in case, let's say for example, sir, 500, sir, ako ang sample size niya, 500 minus 1, it's 499 ba yan? Nya, asa man ko gamiton? Ari ka sa 1,000. Okay? Okay? Nagets? Okay, so let's proceed to one more example, one more item. Again, as I've mentioned, let's talk about these pre-qualifiers. This symbol that you see, guys, is a symbol for population standard deviation, okay? If it's known, use that for z-tests. So if your population standard deviation is given or known, you would have to use z-test, okay? If your population standard deviation, see here, is unknown and is unknown, then you have to use t-test again. So your pre-qualification for you to be able to decide whether it's going to be z-test or t-test, is going to be the population standard deviation. If it's present, then you have to use z-test. If it's not present, you have to use t-test. Clear? All right. So let's work on another type of test. This is still z-test, but this time this talks about proportion. The tests that we talked or we have already covered, z-test and t-test, those are tests for the means. This time we're going to be testing for the proportion, meaning to say we're no longer be talking about the means, but we're going to be talking about the proportion. Okay? So here, um, assume for the testing a proportion. The sample is a random sample. The condition for a binomial experiment are satisfied. These are the qualifiers. First, fixed number of trials, meaning to say dili infinite. You have a specific number of trials. Second, two outcomes only, either yes or no, or success or failure. Next, each outcome is independent, meaning to say whatever the result of the first experiment should not affect the result of the following experiment or second experiment. And then the probability of success must remain the same for each trial, meaning to say, for example, if the first trial has a success probability of 1/2, the second trial should also be 1/2 probability. The third trial should also has 1/2 probability. Okay, so let's work this out here. A dietitian claims that 60% of people are trying to avoid trans fats in their diets. Okay? She randomly selected 200 people, and out of that 200 people, she found out that 128 of them stated that they were trying to avoid trans fats in their diets. At alpha 0.05, is there enough evidence to reject the dietitian's claim? Okay. So, guys, though this is a different type of test, meaning to say this is a z-test per proportion, no longer a mean, the steps are still the same. It doesn't change at all. Okay? So, let's start solving it. Taking a screenshot of this and paste this into our whiteboard here. All right. So, I hope you can hear me. I place the microphone away from my mouth. Let's do step one. Step one, guys, is stating the null hypothesis and the alternative hypothesis. Now, in the previous examples that we have, they are all using the mu sign. They say you are using the mean sign. However, since this is proportion, we're going to be using p, which is the first letter of the word proportion or percentage. So p, and according to the problem, it's 60%. So you have the option to write this way, or you can write p equals 0.60. Okay? The alternative hypothesis, same thing, either greater than, less than, or not equal to. In this problem here, it didn't actually say if it's less than or greater than. So we're going to be using not equal to. P not equal to 60%, or you can write P not equal to 0.60. And which one is the claim? The claim, guys, in this problem is this one. Yeah. All right. So let's work on step two. Step two is still the same, guys, for z-test. So z-test, looking for the critical value. Now, since this is a two-type, or rather not two-type, but a two-tailed test. Why two-tailed? Because of the alternative hypothesis uses a not equal to. So I'm going to write two-tailed test. You have to divide your alpha by 2. Your alpha is 0.05. Dividing it by 2, you would have 0.025, if I'm not mistaken. So in that sense, this means to say that the shaded region or the rejection area has an area of 0.025. And that's the same thing here, 0.025. So to learn or to know what is a critical value here, we need to know first pila area ana kanang unshaded region. So pila area anang na arrow. So it's actually 0.4750 if I'm not mistaken. Sakto ba? Yeah, it's 0.750. So on our Z table, we're gonna be looking at the area. Oops, I stopped share. Wait, I accidentally clicked on stop sharing. We're gonna be looking for the area of the Z table. We're gonna be looking for the area of 44750. Here. So 4750 is here. Do you see the cursor pointed to 0.4750? That means to say, guys, that the critical value is Z 1.96. So this means to say that it's negative 1.96 and positive 1.96. Okay? Now, our step 3 is solving for the test value. This time, we're going to be using a different formula, but this is going to be the formula that we're going to be using. Where are you? Anna. So let me take a screenshot. Anna. Here. So let's start solving for Z. The p hat, guys, is the proportion of the people who stated that they are avoiding the trans fats. So the p hat is a proportion. It's when you say it's proportion, it's percentage. So it's a fraction form. 128 out of 200 people, because there are 200 people in the sample size, and 128 divided by 200, that's actually 0.64. That's the p hat. Okay, the p, guys, it's already given. It's 0.60. The q, guys, is technically 1 minus p. In other words, it's 1 minus 0.60, or q is equal to 0.40. So we just have to substitute the values that we have. 0.64 minus 0.60, 0.60 over square root of 0.60 times 0.40 over n is 200. So you should get 1.15. So let's take a look at an our step 4. Step 4 is the decision making if we were to reject or accept the null hypothesis. 1.15, guys, is located somewhere here, 1.15, because it's 1.96 there. This means to say that we're going to accept the null hypothesis because 1.15 belongs to the acceptance region. This means to say that our step 5 to conclude is to accept the null hypothesis, this one here. So we can say yes. You can say yes, it's true. Let me write it properly. Okay, we're a gubot siya. Yes, it's true that 60% of the people are avoiding trans fats. There you go. All right. So that's it for today, guys. I hope you're able to catch everything that I'm talking about. I am going to upload an assignment later on. So you still have until Saturday to answer the assignments, 11:59 p.m. And next week, which is going to be May 7, I'll have a quiz for starting here. Starting here. One, two, three, and the fourth one. So quiz for these for these four subcategories under fourth quarter coverage. Questions so far? Excuse me. No questions? All right. If there's
None
none,
so
then
far, sir.
good. If there's none, then that's it. Thank you so much for staying on our class for today, guys. And you do have a great day. Enjoy the rest of your week. Enjoy the rest of your day. Buyers. You can just leave, guys. I'm just gonna stop recording the session.